All right, so this week we're going to talk about what the Earth is made of, the physical materials, and that is primarily minerals and rocks. We're just going to briefly touch on minerals. We're going to leave minerals for later in the semester when we talk about resources. We'll actually get some minerals out in the lab, take a look at them, think about what they're used for. And our focus this week really is going to be on rocks. But in order to talk about rocks, we do want to start with minerals briefly because they are one of the primary building blocks of rocks. So minerals are naturally occurring, solid, crystalline substances with known physical and chemical properties. That's the definition from your book. The way a mineralogist would define a mineral is by the crystalline structure and the chemical composition. So those two things are what we use to really define certain minerals. It's kind of like the DNA of a mineral would be the crystalline structure and the chemical composition. Those come together to give the mineral known physical properties, and it's usually the physical properties that we use when we're doing mineral identification. Minerals are generally considered the building blocks of rocks. Over 2,000 different minerals have been identified. Fortunately for us, only a few are common. So if we want to do mineral identification, we can kind of focus in on those. The other minerals, the less common minerals that we will do in mineral identification are ones that we're especially interested in because their content provides some sort of resource that we might be interested in. When it comes down to the common minerals, you're looking at maybe a dozen or 2 dozen minerals that are quite common, and the rest are considered much less common. So the common mineral groups, we put minerals together into groups. The most common mineral group would be the silicates. 98% of the Earth's crust by weight is silicate minerals. Silicate minerals are made up of, kind of at their core, silicon and oxygen, which are the two most common elements in the crust. And then there are other elements mixed in to make all these different minerals. So everything from quartz and feldspar and mica to a whole group of minerals that have iron and magnesium in them. Those are the ferromagnesian minerals. And clay is actually not a single substance. It's actually a type of mineral, and there are several different minerals that fit into the group that we refer to as clay. Some other common mineral groups that are important would include the oxides. The oxides are very important because they are made of a combination of oxygen and a metal element like iron or aluminum. And so they're very important for mining. The carbonate minerals include a mineral called calcite, which is a very common mineral at the Earth's surface. And a lot of calcite is actually made by living organisms. Coral and clams, for example, both use calcite to make their shells. The sulfides are similar to the oxides in that they are a combination of a sulfide ion combined with, or sulfur ion, I should say, combined with a metal ion. And so when those two are together, you get a mineral like pyrite, but you can actually mine pyrite and remove the iron. And then we have the native elements, which are just straight up one element like gold, silver, copper, and diamonds. So those are some common mineral groups. And this is a table from your textbook that kind of highlights some of the minerals in the group and has some comments on why they're important. Under quartz, for example, I would actually put, there's a whole bunch of uses for that we'll discuss later in the semester, but notably in our area, silica sand is almost pure quartz sand, and it's very good for glass making. So enough about minerals. We need to move on to rocks. Rocks are solid aggregates of earth materials. So typically they're made of minerals, but they could also be made of organic material like wood. They could also be made of amorphous material, which is not crystalline, and therefore not a mineral, and that would be something like volcanic glass. So the definition of rocks is very, very broad, just a solid aggregate of earth materials. It encompasses many, many things. The way we classify rocks are based on their origin, their composition, and their texture. And the first division that we use is the origin. There are 3 very broad rock types. Igneous rocks, which we will discuss first, form from the solidification of molten rock. Sedimentary rocks form from sediments, which is loose material, in many cases derived from rocks, but loose material like sand and gravel. It could be organic material like wood or shells that is then buried and lithified or turned into stone. So sedimentary rocks. And then the third origin is through intense heat and pressure, and that would give us the rock type metamorphic rocks. So igneous, sedimentary, and metamorphic are our 3 rock types. And then once you're in a rock type, you look at what is this rock made of, so what's its composition, and then what's its texture. And the term texture we use to describe the size, shape, and arrangement of whatever materials the rock is made of. So it could be minerals or shells or something else. And so the texture tells us about the size, shape, and arrangement of that material. So that's how we identify individual rocks. We first put them into a group based on their origin, and then we look at their composition and texture. So the first group that we're going to look at are the igneous rocks. These form from the solidification of molten rock. And this can happen in one of 2 places. It can happen below the Earth's surface. So those rocks we would call intrusive, because the molten rock comes up from even deeper in the Earth. So it intrudes existing rock. And so those rocks we call intrusive. They're also often called plutonic. Pluto was I think the Roman god of the underworld, and so because these rocks form under the surface, plutonic. The other place molten rock can cool and solidify is at the surface, like near a volcano, and so that we would call extrusive igneous rock because it's been extruded from the ground at the volcano. The other term for these rocks are volcanic. And Vulcan is the Roman god of the forge or the volcano. So once we've split them into where they cooled, we also look at their composition. And these are really broad compositional groups. If you were to study to become a geologist, it becomes much more specific than this. But mafic, intermediate, and felsic are based on the group of felsic minerals that are present in the rock. The mafic minerals, and all these minerals have a lot of silicon and oxygen. The mafic minerals also have iron and magnesium, as well as calcium in them. The felsic rocks down at the bottom of our little list here have silicon and oxygen, but they also have a lot of aluminum, potassium, and sodium. And then the intermediate rocks fall somewhere in between. And we'll look at the chart for classification in a few slides. So what's actually going on here? Well, igneous activity starts with molten rock. And molten rock forms when existing rock melts. It turns out that the Earth is mostly solid. Next week we'll talk about plate tectonics. We'll take a quick peek inside the Earth. But what we'll find is that the Earth's crust, which is the outer layer, and the mantle, which is the next layer down, are both solid. And so something has to happen to melt the rocks in order to start the igneous process. And that could be the temperature increasing. It could be a decrease in pressure. It turns out it's already quite warm down there, If you go below the surface, it gets warmer and warmer the deeper you go, but the high pressure prevents the rocks from melting. So if something happens to reduce the pressure, that can trigger melting. And the other thing that can trigger melting is a chemical change, like if you add water. And when we talk about plate tectonics next week, we'll look at different environments where these three things occur. Once you have molten rock, once the rock has melted, it rises up to the surface because molten rock is less dense than solid rock. And so it rises up to the surface, it intrudes existing rock, and it may be that as it intrudes existing rock, it cools off and solidifies. Or in some cases, it makes it to the surface and gives us a volcano. So our intrusive activity, we call the molten rock magma. The texture of the rock, because it cools slowly, means you usually have some pretty large crystals. And by large, we mean they're definitely visible to the naked eye, and in some cases, they get quite large. They can be several inches, or in some unusual cases, several feet long. The different types of intrusive bodies are shown in your textbook in a diagram. I didn't include the diagram here, but these are some of the names that we give to intrusive rock bodies. The extrusive igneous rocks, the molten rock is called lava when it comes out on the surface. The feature that forms, of course, is a volcano. And when the molten rock comes on the surface, it cools very quickly. And so that gives us textures where we cannot typically see the mineral crystals. So we say that these rocks are fine-grained. In some cases, the molten rock cools so quickly that they're glassy. And the release of pressure when the volcano erupts allows bubbles to form. And so very often these rocks will have bubbles in them. Bubbles doesn't sound very science-y, so we use the term vesicles. And so we would say those rocks are vesicular. And there's the names of some of these rocks on the slide as well. So the way the classification works is we look at the composition, and you'll notice there are 1, 2, 3, 4, 5, 6, 7, 8 different minerals listed here. So these are the very common silicate minerals that we find in the crust. And depending on which group of silicate minerals you find, gives you the different compositions of the igneous rocks. We also look at the texture. The fine-grained rocks are extrusive, so these are rocks with minerals that are too small to see with the naked eye, for the most part. And the intrusive rocks are rocks that have minerals that are large enough to see with the naked eye. And so if you combine those characteristics, the composition and the grain size or the texture, you get these different igneous rock names. You'll notice that the felsic rocks over here have quartz, potassium feldspar, which is pink, and these other minerals. And the mafic rocks, which are over here, have olivine, pyroxene, and this calcium-rich plagioclase feldspar. These rocks tend to be dark. These rocks tend to be light or pink. And then the ones in the middle tend to be gray. And then some of the important properties of these rocks are they are a source of economic minerals and rocks. They tend to be very strong. You'll see this down in the lab. That will be one of the focuses that we have in the lab, is kind of characterizing what these rocks are like when you find them. These tend to be very strong and resistant to weathering. The crystals are tightly bound, so fluid can't get in there. The extrusive igneous rocks are the opposite. They tend to be weaker, although they are pretty strong in most cases because of the interlocking crystals. However, when they form at the surface and you can get bubbles and other things going on, they can be much more susceptible to weathering. Fluid can flow through them more easily, and they tend to be less strong. The next set of slides will talk about the sedimentary and the metamorphic rocks.